This is the maintenance section, in which the various tasks involved in a compressor service will be explained and demonstrated. The first service topic we shall describe is that of lubrication. Most industrial compressors require adequate lubrication in the form of oil. The first important check is to see that the level is correct. The oil level determines the amount of oil being held within the crankcase. There are three main types of oil level checking devices, namely the sight glass, the level plug, and the dipstick. Checking the oil level. It is important that the oil level is checked only when the unit is stopped and has been at rest for a few minutes. This delay allows time for the oil to settle in the crankcase. Where a level plug is used, begin by cleaning the plug and the surrounding area. Using a suitable spanner, slacken and then remove the plug. Observe the oil level through the hole, where, if full, the oil should reach the top edge of the filler neck. If oil cannot be seen inside the filler neck, then the compressor is low on oil. To check the oil level with a sight glass, observe the glass, wiping it clean if necessary, and check the level of the oil against the indicated mark, or ensure that the level is at or near the top of the glass. Oil should always be visible in the glass window. On models with dipsticks, begin by cleaning the area around the dipstick. Remove the stick and wipe it clean. Return the stick into the tube or hole and push it fully down. Remove the stick again and, keeping it upright, observe the oil mark. The oil should reach the full mark, or at least be above the low mark. Topping up simply means adding sufficient oil to return a low level to a full level. First, it is very important that you know what type and grade of oil is to be used. Adding the wrong oil can result in major damage to a compressor. There are three ways in which you can find out the correct oil to use. Firstly, you can check the unit's operating manual. Or you can look on the unit for the specification label or plate. Or you can ask your supervisor. We don't need dirt or other contaminants entering a compressor. So, before topping up, make sure that everything is wiped clean. Remove the oil filler cap and pour the oil slowly into the compressor. If you try to speed up this process, the oil will blow back and will be wasted, besides making an oily mess everywhere. Add sufficient oil to bring the level up to the relevant full mark, but do not overfill the unit. Replace the filler cap as soon as the topping up has been completed to reduce the chance of contaminants entering the compressor. Oil must be changed at regular intervals, according to the manufacturer's recommendations, in order to extend compressor life. An oil drain plug will usually be found at the base of the crankcase. For best results, oil should be drained whilst the compressor is at operating temperature and with the filler plug removed. Place a suitable catcher container below the drain plug, and then remove the plug. As it can take quite some time for all the oil to flow out, you might want to attend to other tasks while this is going on. Certain clues about the compressor's condition can be obtained by checking the condition of the oil as it drains. New, fresh oil is always clear and clean in appearance, although colors may vary between different manufacturers. Oil is designed to hold dirt and contaminants in suspension as it works, and this is why you will find that it goes dark after many hours of normal operation. Something is wrong if the oil appears milky when you check or drain the system. Something is also wrong if the oil is black, thick, and smelly. Both these conditions should be reported for further investigation. When the oil has completely finished draining, then the drain plug must be replaced. Check the thread condition of the drain plug. Damaged threads could result in a leak. It is suggested that thread tape be applied to minimize the chance of a leak where plain plugs are used. Replace and secure the drain plug. Next, obtain the correct quantity and type of oil. Fill the crankcase to the proper mark in the manner described for topping up. In some instances, such as we have here, the filler plug incorporates a sealing device to prevent dirt from entering the crankcase. On this plug, it is an O-ring. On other plugs, it may be a copper washer. Make sure that this seal is in place and is in good condition. Replace the filler cap or plug and wipe away any spills. In summary, when dealing with lubrication, the important points are using the correct and recommended type of oil and keeping everything clean as you work. Draining the condensate. Condensate is the term used to describe the water that collects in air systems from the condensation of airborne moisture. On most tank-mounted compressors, the condensate is normally drained manually from the receiver. The drain valve is situated beneath the tank and will always be at the lowest point. If the drain valve is not connected to a waistline, then place a catcher tin beneath the valve to commence the job. Slowly open the drain valve and allow the water to drain off. You don't need to open the valve fully, as this will only waste air. Failure to drain the condensate on a regular basis, especially in warm weather, will result in excessive water entering the system. In this section, we will describe air filter service operations. The fundamental purpose of an air filter is to prevent solid particles from entering the compressor and the rest of the system. The most common type of air filter comprises a filter housing, in which you will find a dry-type filter element. Most dry filter elements are constructed of a special type of paper through which the air will flow. The paper is known as the filter medium. Dirt and solid particles become trapped in the medium, and eventually the filter can become clogged. When a filter is clogged, the air cannot easily pass through, and the compressor will not provide its proper delivery. For this reason, a filter element must be either cleaned or renewed periodically. If the local conditions around the compressor are simply dusty, then a filter element can be cleaned. We shall now describe a typical cleaning procedure for a dry-type filter element. Begin by wiping away the dust and accumulated dirt from around the filter housing. Remove the securing nut and then take off the housing. Separate the element from the filter housing. As our demonstration unit has done no real work, the element is still very clean. This is not a normal situation. In an industrial environment, an element may become very dusty. A few taps against your hand will dislodge the heavy dust particles. Now, with the shop air hose and the duster gun, blow the filter from the inside. Note that you must not use a pressure higher than 3 bars for this operation, or you will damage the filter medium. Blowing from inside to the outside forces the particles to be pushed out the way they entered. If you try to blow from the outside, you will, in effect, be pushing the particles deeper into the filter medium, and this will result in further clogging. In this example, the element is contaminated with a greasy residue, caused, most possibly, from local fumes. This element cannot be cleaned using the air hose, and it will need to be discarded. Use an inspection light inside an element and check for any small holes or tears in the filter medium. We should never reuse an element that is damaged, as dirt can enter the compressor through very small holes or tears. Although a very basic task, the fitting of a filter must be done correctly to avoid dust entering a compressor. Wherever the filter housing is threaded into the cylinder block, it is always recommended that thread tape is used to seal the threads, thereby minimizing the risk of dirt bypassing the filter. Wipe the filter housing to remove dust and dirt before you replace the element. Assemble the unit carefully, making sure that the element sits properly on its mounting or base. Replace the cover. Where applicable, but very importantly, replace the washer that sits beneath the retaining nut or screw. If you leave this off, you run a great risk of dirt entering the compressor. Fit and secure the retainer, but do not over-tighten. Where flat metal covers are used, check that the cover sits flush to the housing and that there is no distortion. A distorted cover will permit dirt to bypass the element and enter directly into the cylinder. In this section, we shall deal with the procedures involved with servicing drive belts. When working on the drive belts, it is vital that the compressor is totally isolated from the power supply. To perform this task, you will usually need to remove the safety guard. With the guard removed, check each belt for signs of wear or damage. Rotate the flywheel carefully so that you can inspect the full length of each belt. Check the tension, making sure that the tension is equal between all the belts. If the tension is not equal, then a new match set of belts will have to be installed. Where applicable, adjust the tension in the appropriate manner. Note that the subject of belt maintenance is fully covered in Tech AV modules B-C-D. To complete the task of belt maintenance, refit the guard and check that it is secure. Certain routine checks can only be made with the compressor operating, or when there is pressure in the receiver. We shall look at these tasks in this section. Every receiver must have a safety valve, and these must be checked to see that they operate. The task is very simple. With the compressor operating at or close to its maximum operating pressure, simply pull the spindle using the pull ring and then let it go again. Air should release and then shut off quickly when you release the ring. If a safety valve does not release air or does not shut off quickly when released, then report this to your supervisor. Two-stage compressors have a safety valve on the interstage outlet. Test this valve in the same manner as the tank valve. Note that this valve will only operate whilst the compressor is running. Compressors equipped with a cutout should be tested to see that the cutout is correct. This, too, is a very simple task. Close the main supply valve in order to keep the pressure restricted to the receiver only. Simply note the pressure at which the compressor motor cuts out. This pressure should be limited to the system pressure set for your system by your plant engineers. Although the cut-out and the cut-in pressures can be adjusted, you must not make any adjustment on your own. When necessary, ask your supervisor to check the pressure and to make any adjustment. Reciprocating compressors are prone to vibration, which results in the need to check the fasteners on a regular basis. Begin the fastener check only after making absolutely sure that the unit is switched off and isolated. Use suitable spanners to check and secure the mounting supports for both the motor and the compressor pump unit. These fasteners need regular attention. A check should be made on all the pipe unions as well. Loose unions will result in leaks and power wastage. Do not overlook items such as the belt guard supports during the fastener check. Although it seems unimportant, the cleaning of a compressor unit is vital to its operation. Any air-cooled machine relies totally upon an efficient heat transfer between the metal parts and the surrounding air. Anything that interferes with this heat transfer, such as dust and dirt, will cause overheating, and this in turn will result in premature failure of a compressor. The simplest way to clean a dusty compressor is to blow off the dust using an air gun. Make sure that you are wearing your safety goggles or other suitable eye protection. Blow from top to bottom all over the compressor unit, keeping the nozzle directed away from your body. Pay attention to the cooling fins. Blow away all debris and dust from these areas. Use the nozzle of the air duster gun to get into the intercooler fins. You will notice here on our training model that the fins are coming away from the tubing. This sort of problem will result in poor performance of the compressor. An intercooler in such a condition should be repaired as soon as possible. The drive motor too should be kept free of dust and dirt. A word of warning here: never wash a motor with water or any other fluid, as this could lead to your being electrocuted. A clean compressor is generally a healthy compressor, because, as you now appreciate, cooling will be more efficient and the chance of overheating will be greatly reduced. To conclude this module, we would like to offer a final piece of instruction concerning the starting and stopping of a compressor. As a general rule, always start and stop a unit at its control switch, which is usually incorporated into the cutout control box. It is not recommended to stop a unit directly from the power point. In fact, some compressors will be badly damaged if you do this. After a service, operate the compressor and keep an eye on things for a few minutes, or until it is obvious that all is well. This concludes Module 2 in this series. You can learn more on the subject of compressed air systems maintenance by working through the other modules in this series.